Hello students, myself Dr. Chandraprabha from Department of Chemistry. Today we are going to discuss some important questions for the competitive exam from P block elements, that is group 13, 14 and 15. So before starting with the questions, we will just observe what are the important topics that you should cover in this chapter, that is anomalous behavior of boron, carbon and nitrogen, general trends, oxidation states, compounds of boron, in that especially you have to study the reactions of orthoboric acid, in nitrogen, ammonia and nitric acid, and in phosphorus you have to remember each and everything regarding the phosphine, especially in general their physical and chemical properties. Next, reactions of orthoboric acid, structure of diborane, allotropes of carbon, isotopes, oxidizing property of HNO3. Next, reactions of nitrogen with oxygen, halogen and hydrogen. So, the oxides, halides and hydrides. Regarding this, you have to remember the thermal stability, bond dissociation enthalpy, reducing character and acidic character in general, oxides of nitrogen and oxoacids of phosphorus. So, in this you have to remember the oxidation state, acidic character, basicity and the structure of all these oxides and oxoacids. In preparation, the preparation of orthoboric acid and preparation of pure nitrogen, Haber's process for ammonia and Oswald's process for nitric acid. Last is the Brown ring test that you have to remember. Let's start up with a question. Question number 1. Aqueous solution of borax is acidic, neutral, amphoteric or alkaline. When borax is treated with water, you are going to get orthoboric acid H3BO3 and OH minus ions. So, we will balance the equation. So, you are going to get the OH minus ions. So, due to the formation of the OH minus ions, the solution is alkaline in nature. Hence, the correct option is option number 4. Question number 2. Specify the coordination geometry around the hybridization of nitrogen and boron atoms in 1:1 complex of BF3 and NH3. If you observe the BF3 and NH3 molecules, in case of BF3, in boron, the hybridization is sp2 and the geometry is trigonal planar. Whereas in the case of ammonia, the hybridization of nitrogen is sp3 and the geometry is pyramidal. But such options is not observed here. So, this is a special case where 1:1 ratio of BF3 and NH3 if we consider. Boron being an Lewis acid, it is going to accept a lone pair of electron from the nitrogen and it is going to form a bond. So, we will consider the electronic configuration of boron. Boron is 2s2, 2p1. So, if I write the ground state electronic configuration, it will be like this. Excited state electronic configuration is the lone pair of electron which is accepted from the nitrogen, we can accommodate in the last hybrid orbital. Hence, the hybridization is sp3. So, that is boron is sp3 hybridized. And if you want to find out the geometry, you can observe there are 4 bond pairs of electrons. So, 4 bond pairs of electrons, hence the geometry is tetrahedral. If you go for ammonia, the ammonia molecule is like this. There is no change in the hybridization in the case of nitrogen. It remains as such, that is sp3 hybridized, but the lone pair of nitrogen, that is the lone pair of electron on nitrogen is converted into bond pair. As a result, there are 4 bond pairs of electrons are present. 4 bond pair. So, the geometry is tetrahedral. boron sp3 hybridized tetrahedral, ammonia sp3 hybridized tetrahedral. So you can observe here, hence the correct option would be answer 1. Question number 3. The least acidic in the series of BF3, BCl3 and BBr3 is BF3 because. So you have to find out the reason why BF3 is least acidic. If you observe the options, fluorine is most electronegative, fluorine has a very small size, B3 plus has a very small size, back donation of electrons from fluorine to boron occur. If you observe the BF3 molecule, here the boron and fluorine atoms are very small. So as a result, what happens is the atomic orbitals of fluorine overlap with the atomic orbital of boron. So electron density around boron increases, thereby acidic character decreases. This concept is called as back donation of electrons, hence the correct option is 4. Answer is 4. Next question. Aluminium and gallium have nearly the same covalent radii because of. If you observe the option, they have given greater shielding effect of s electrons of gallium atoms, poor shielding effect of s electrons of gallium atoms, poor shielding effect of d electrons of gallium atoms, greater shielding effect of d electrons of gallium atoms. So in the case of gallium, there are 10 d electrons are present. So these are very poor shielders. That is, due to the poor shielding effect of d electrons, the size of the gallium is less than expected. As a result, aluminium and gallium have the nearly same covalent radii. So the poor shielding effect of d electrons is observed in the option number 3. Hence, the correct option is 3. Question number 5. Boric acid H3BO3 and BF3 have the same number of electrons. The former is a solid and the latter is a gas. The reason is, in the case of the boric acid can also be written like this, BOH thrice. So in this, the oxygen atom is highly electronegative and hydrogen atom is highly electropositive. So due to the presence of this highly electronegative oxygen and highly electropositive hydrogen, there is a strong intermolecular hydrogen bonding, due to which there is a molecular association. Hence, the boric acid is existing as a solid state. Whereas in the case of the BF3, if you observe BF3, there is no such molecular interactions or hydrogen bonding is present. As a result, BF3 exists as a single molecule which is in the gaseous state. So option number 4 is correct. No molecular association is possible in BF3 but possible in BOH thrice due to hydrogen bonding. Question number 6. On the addition of mineral acid to an aqueous solution of borax, the following compound is formed. So this question already we have discussed in the previous one. If you observe the reaction of orthoboric acid when it is treated with mineral acid like HCl, the chlorine will combine with the sodium to give you sodium chloride. So one more product is nothing but H3BO3, that is 4 molecules of H3BO3 is formed. So this is nothing but orthoboric acid. Hence the correct option is 2. The answer is 2. Question number 7. The liquefied metal expanding on solidification is aluminium, gallium, zinc, copper. If you observe the 4 options, gallium is liquid at room temperature. It expands 3.1% on solidification. Option is 2. Question number 8. Boric acid, when you heat at 100 degrees Celsius, it is going to give you compound X, which upon further heating at 160 degrees Celsius, it is going to give you another compound Y. Upon further heating, it is going to give you boric anhydride. You have to identify what is X and Y in the given reaction. So, when orthoboric acid is heated at 100 degrees Celsius, it is going to give you HbO2, that is nothing but metaboric acid. Which on further heating at 160 degrees Celsius, it is going to give you another compound, that is tetraboric acid. Which upon further heating at red hot is going to give you boric anhydride. Here X is nothing but metaboric acid and Y is nothing but tetraboric acid. So, it is option number 1. Question number 9. In diborane, if you observe the option, all the options are related to the structure of the diborane. So, we will write the structure of diborane. In diborane, the 2 boron atoms and 4 terminal hydrogen atoms are in the plane, whereas the 2 other hydrogen atoms are out of the plane, and these are 3-centered 2 electron bonds, and these are also called as banana bonds. So, we will go for the options now. Option number 1, there is a direct boron-boron bond. If you observe, there is no direct boron-boron bond, hence the option 1 is wrong. Second one, the boron atoms are linked through hydrogen bridges. So, that is correct. You can observe the 2 hydrogen bridges. So, the option number 2 is correct. So, we will just cross check with the other options too. The structure is similar to ethane. If you observe the structure of ethane, here all the hydrogen atoms lie in the plane and there is a carbon-carbon bond, whereas this type of structure is not available in the case of diborane. Hence, the option number 3 is wrong, and here option number 4, all the atoms are in the plane, the 2 hydrogen atoms are not in the plane, hence the option number 4 is also wrong. So, the correct option is option number 2. Question number 10, the stability of +1 oxidation state increases in the sequence. You know that the stability of the lower oxidation state always increases down the group, and if you observe the options here, all the elements are from group 13 elements. So, if I write the group 13 element, it is aluminium, gallium, indium and thallium. So, the stability of +1 oxidation state increases down the group in the order. So, it should be in this particular order. Hence, the option is 4. Question number 11, borazole B3N3H6 is related to benzene as. If you observe the option, it is mainly about isoelectronic, isostructural. So, we will write the structure for borazine and benzene. If you observe the structure of borazine and benzene, if you observe the structure, both the structure are very much similar. So, we can tell that these are isostructural in nature, whereas there is one more option, that is regarding the isoelectronic. We have to check whether these are having same number of electrons or not. So, if you observe in the borazine, there are 1, 2, 3, 4, 5, 6 hydrogen atoms, which compensates for the electrons of 6 hydrogen atoms in the benzene, and in the case of borazine there are 3 nitrogen atoms and 3 boron atoms, and in the case of benzene you have got 6 carbon atoms. The valence electrons of carbon is 4, whereas the valence electrons of boron is 1 less than the carbon. The valence electron of nitrogen is 1 more than the carbon. As a result, 3 boron atom and 3 nitrogen atom electrons compensate for the 6 carbon electrons. As a result, both the structure are isoelectronic as well as isostructural. Hence, the correct option is option number 3, both A and B. Question number 12. Borax is converted into crystalline boron by the following step, that is borax Na2B2O7. So, when you treat it with X, it is going to give you orthoboric acid, and when you heat it further, it is going to give you boric anhydride, which upon treating with Y, you are going to get boron. So, boric anhydride here is converted into boron, that is you have to use some reducing agent. In the option you can check for the given reducing agent, that is magnesium, carbon and aluminium. So, out of this the aluminium is a very suitable reagent. This is because aluminothermite process is mainly used for the conversion of boric anhydride to boron, hence it should be aluminium. Next, if you go for X, borax is converted into orthoboric acid. In one of the previous question already we have discussed, we are going to use mineral acid. Another option is carbon. So, you cannot use carbon because carbon is a reducing agent. So, you have to use a mineral acid HCl. So, X is HCl, Y is aluminium. This is observed in the option number 4. Hence, the correct option is 4. Question number 13. Which of the following is formed when alumina and carbon is heated strongly in dry chlorine gas? When alumina is treated with carbon and dry chlorine gas, you are going to get aluminium chloride. So, that is given in the option. So, if you observe, carbon will combine with oxygen to give you carbon monoxide, and one more product is aluminium chloride. So, 3 carbon atoms, 3 carbon monoxide you are going to get, and 2 aluminium chloride. So, here one more thing you have to remember, they are asking which aluminium chloride, whether it is hydrated one or anhydrous. If you observe the reaction, there is no proton at all, or hydrogen atom is not present in the reaction. And one more thing, the temperature maintained is 100 degrees Celsius. So, it should be anhydrous aluminium chloride. Hence, the option is 3. Question number 14. Aluminium hydroxide is soluble in excess of sodium hydroxide, forming the ion. So, if you observe the reaction, when aluminium hydroxide is treated with sodium hydroxide, you are going to get sodium aluminate. The formula of the sodium aluminate is NaAlO2. So, the ion you have to find out. NaAlO2, that is nothing but AlO2 minus. Hence, the correct option is 3. Question number 15. In commercial electrochemical process for the extraction of aluminium, the electrolyte used is. In commercial method for the preparation or the extraction of aluminium, we are going to use Hall-Hérold process. In the case of the Hall-Hérold process, the electrolyte that we are going to use is fused alumina and cryolite, that is observed in the option number 3, that is molten mixture of alumina and cryolite is used. Hence, the correct option is 3. Question number 16. Identify the incorrect statement. Crystalline silicon is prepared from silicon tetrachloride. So, this statement is correct. So, when silicon tetrachloride is treated with aluminium, it is going to give you aluminium chloride plus silicon. So, this statement is correct. Next option, if you go, amorphous silicon is chemically more active than crystalline form. Even this statement is also correct. This is because in the crystalline arrangement, there is more ordered arrangement in the structure, and the structure is more stable, and it is less reactive. Whereas in the case of the amorphous silicon, due to the random arrangement or disordered arrangement, so what happens is the structure is not stable and it will be more reactive. Hence the second statement is also correct. If you go for the third statement, silicon tetrachloride is readily hydrolyzed. In the silicon, there is a presence of vacant d orbital, due to which the silicon tetrachloride is readily hydrolyzed. The third statement is also correct. If you go for the option number 4, silicon hydrides are known as silicon. So this is a wrong statement because silicons are nothing but organosilicon polymers. Silicones are organosilicon polymers with the general formula R2SiO. Hence, the statement 4 is wrong. Hence, the correct option is 4. Question number 17. Graphite is a good conductor of electricity because it contains. So, for the conduction of electricity, there should be a presence of free electrons or mobile electrons. So, this is a direct question. You can observe the option number 2, mobile electrons are present, due to which the graphite is a very good conductor of electricity. Question number 18. Which of the following is not hydrolyzed? So, in the previous question already we have discussed, for the hydrolysis we require a vacant d orbital. If you observe here, central atom, carbon, silicon, tin and lead. So, silicon, tin and lead, you have got vacant d orbital, hence these are easily hydrolyzed, whereas in the carbon there is no vacant d orbital, hence it is not hydrolyzed. Hence the option is 1. Question number 19. A metal M forms chlorides in its +2 and +4 oxidation state. Which of the following statement about these chlorides is correct? Option number 1. MCl2 is more ionic than MCl4. So, according to the Fijns rule, it tells that metal in lower oxidation state is more ionic than in higher oxidation state. Hence, the statement 1 is correct. If you go for the other options, second one, MCl2 is more easily hydrolyzed, this is wrong because MCl4 is having more covalent character, hence that will be more easily hydrolyzed. MCl2 is being more and more ionic in nature, it cannot be volatile and it cannot be easily soluble in ethanol. Hence, the option 2, 3 and 4 are wrong. The correct option is option number 1. Question number 20. Carbon dioxide is gas while SiO2 is solid. This is because. So, in the case of carbon dioxide, it is a linear molecule and single molecule, whereas in SiO2, so the SiO2 is going to associate to each other to form a 3-dimensional network like structure. As a result, carbon dioxide is gas while SiO2 is solid. You can observe that in option number 2. Hence, the correct option is 2. Question number 21. Which statement is correct with respect to the property of the elements with increase in atomic number in the carbon family? They are asking with respect to carbon family, that is down the group. Their metallic character decreases. You know that when you move down the group, the metallic character is going to increase. So, the first statement is wrong. And in the option number 2, the stability of +2 oxidation state increases. This is correct because the stability of lower oxidation state always increases down the group. We will just cross check with the other 2 options. Their ionization energy increases. This is wrong. This is going to decrease. The atomic size decreases. This is also wrong. This is increases. So, the correct statement for this question is option number 2. The stability of +2 oxidation state increases, which is not an allotrope of carbon. If you observe the options are graphite, diamond, soot and carborundum. Graphite, diamond and soot are allotropic forms of carbon, allotropes of carbon. The fourth option, carborundum, sounds like carbon compound, but it is not a carbon compound, it is nothing but silicon carbide. Hence, the allotrope of carbon is graphite, diamond and soot, but it is not carborundum. Question number 23, name the structure of silicate in which 3 oxygen atoms of SiO44 minus units are shared. So, they have given you 4 options: pyrosilicate, linear chain silicate, sheet silicate, 3-dimensional sheet silicate. In the pyrosilicate, the number of oxygen atoms shared is 1. In linear chain silicate, the number of oxygen atoms shared is 2. In sheet silicate, the number of oxygen atoms shared is 3. In 3-dimensional sheet silicate, the number of oxygen atoms shared is 4. So, in the question they are asking in which 3 oxygen atoms are shared. So, the 3 oxygen atoms are shared in sheet silicate. Hence, the correct option is option number 3. Question number 24. Which one of the following anions is present in the chain structure silicate? So, in the previous question already we have discussed the number of oxygen atoms shared here. So, in the case of chain structure silicates, the number of oxygen atom shared is 2. So, we know the structure of silicates is obtained by sharing oxygen atoms. So, this is a unit SiO44 minus. In this, 2 oxygen atoms has been shared. So, we will take 2 molecules. So, 2 molecules will be Si2O8 minus, share 2 oxygen atoms here. So, it will become Si2O6 2 minus, hence the formula will be Si2O6 2 minus, that is option number 3. Question number 25, which one of the following statement about zeolite is false? So, zeolites are nothing but aluminosilicates. So, we will go for the option number 1, they are used as cation exchanges. This is correct. So, silica and aluminium are the cations that is present, so which can be used as a cation exchanger. They are open structure, take up of very small molecules. So, these zeolites are also called as a molecular sieves. Hence, the second option is also correct. If you go for the third option, none of the SiO4 4 minus units are replaced by AlO4 5 minus units. So, this is wrong because already we have discussed that zeolites are nothing but aluminosilicates. So, SiO4 4 minus units are replaced by AlO4 5 minus units. Fourth option, they are 3D aluminosilicates. So, this option is correct. So, the wrong statement in the given option is, given question is option number 3. 26. Silicon have strong tendency to form silicon polymers. The chain length of these polymers can be controlled by adding. So, for this we are going to use trimethyl silyl chloride. The mechanism follows in this way. Hence, the correct option is 3. Question number 27. Which of the following is similar to graphite? So, the options are boron, boron nitride, B2H6, B4C. Among the given option, the boron nitride is having hexagonal structures which is very much similar to your graphite. Hence, we can go for the option number 2. The correct option is 2. 8. The correct order of increasing carbon-oxygen bond length of carbon monoxide, carbon dioxide and carbonate ion is. If you observe the bond order of these 3 molecules, that is carbon monoxide, bond order is 3, carbon dioxide, it is having a double bond, so bond order is 2, carbonate ion CO3 2 minus, the carbonate ions is having partial double bond character, so we can take the bond order as 1.3. So, they are asking for the bond length. So, you should know the relation between the bond length and bond order. They want increasing CO bond length, increasing bond length. Bond order and bond length are inversely related to each other. So, bond order decreases, bond length increases. So, who is having the highest bond order here? Carbon monoxide. So, it will be having the least bond length. So, the order is like this: carbon monoxide, next comes carbon dioxide, next comes carbonate ion. Hence, the correct option is option number 4. Hence, the answer is 4. Question number 29, PbF4, PbCl3 exists, but PbBr4 and PbI4 does not exist. So, if you observe the lead is having two oxidation state, Pb4 plus and Pb2 plus. In the presence of the strong oxidizing agent fluorine and chlorine, there is a oxidation reaction. So, Pb2 plus is readily converted into Pb4 plus. So, there is a oxidation reaction. In the presence of bromine and iodine, bromine and iodine are mild oxidizing agent, hence it will prefer reduction, or in other words I can tell that these are a strong reducing agent. So, there is a reduction reaction. Hence, Pb plus 4 does not exist, Pb2 plus exists. This is the actual reason PbBr4 and PbI4 does not exist. But such options are not available in the given question. Large size of Br minus and I minus, low electronegativity of Br minus and I minus are present, but these are wrong. So, we have to go with the option number 2 and 3. So, in 2 and 3 you can observe the strong oxidizing character of Pb4 plus, strong reducing character of Pb4 plus. So, this is reduction reaction, hence Pb4 plus is showing strong oxidizing character, hence option number 2 is the correct answer. Number 30, which one of the following combines with Fe2 plus ions to form a brown complex? So, this is a direct question. So, when Fe2 plus ions combines with a nitric oxide, it is going to give you a brown complex. So, this is nothing but a brown ring test. Hence, the correct option is option number 1. 31, extra pure nitrogen can be obtained by heating. You know that the pure nitrogen can be obtained by decomposition of barium or sodium azide. So, the barium azide is observed in the option number 4. Hence, the correct option is 4. Question number 32, which of the following nitrogen oxides is an anhydride of nitric acid? Anhydride is a chemical compound which is obtained by elimination of water molecule from another compound. So, if you observe the nitrogen oxides is an anhydride of nitric acid, HNO3. That means if you want to find out the oxides of nitrogen, you have to remove the water molecule from nitric acid. So, I want 2 hydrogen atoms, so I will take 2 molecules of HNO3, that will be H2N2O6. If I remove water molecule from this, it will be N2O5. Hence, the option 1. Question number 33, P4O10 has short and long PO bonds. The number of short P double bond O bonds in this compound is. So, this is a very direct question. If you know the structure of the molecule, easily you can find out the answer. They are asking for short P double bond O bonds. In the structure you can observe 1, 2, 3, 4. 4 short PO bonds are present in this molecule. Hence, the option is 4. Question number 34, the oxidizing property of nitric acid is due to its concentration, positive valency of nitrogen, its dilution, presence of nitrogen in its higher oxidation state. If you observe the nitric acid, the formula of the nitric acid is HNO3, and if you calculate the oxidation state of nitrogen in this, the oxidation state of nitrogen is +5. So, this is the highest oxidation state for nitrogen. So, in the reaction, this highest oxidation state will be reduced to lower oxidation state. So, that is why the oxidizing property of the nitric acid is mainly due to this highest oxidation state. Hence, the correct option is option number 4. Question number 35, the equivalent weight of phosphoric acid in the reaction. So, you should be very careful in this question because they are asking the equivalent weight of phosphoric acid in the reaction. So this is because the basicity of the phosphoric acid is 3, but they are asking in the question, so you should observe the number of water molecules dissociated here. The number of water molecule dissociated is only 1, hence the proton used in this particular reaction is only 1. So I can consider the basicity is equal to 1 since only one H plus ions is dissociated during the reaction. So in order to calculate the equivalent weight is equal to molecular weight into basicity. So already we have found out basicity is nothing but 1, hence equivalent weight is equal to molecular weight. So we will calculate the molecular weight of H3PO4, 3 into 1 plus 31 plus 4 into 16, put together it will be equal to 98. So the option number 4 is correct, that is 98. Question number 36. Which of the following acid forms 3 series of salt? If you want to find out the 3 series of salt, then the basicity of these acid should be 3. So you find out in which case the basicity is 3. If you go for this one, option number 1, this is hypophosphorus acid, where the basicity of this acid is 1. Boric acid, the basicity is 1. This is phosphoric acid, basicity is 3. Phosphorus acid, basicity is 2. Among the given option, the option third one is having basicity 3, hence it can form the 3 series of salt, hence the correct option would be 3. 37. The molecule having smallest bond angle is. If you observe the given options, here all the surrounding atoms are same but the central atoms are different. According to the rule, when a molecule is having same surrounding atoms and different central atoms, the bond angle is directly proportional to electronegativity of central atom. So if you observe the elements here, it is nitrogen, phosphorus, arsenic, antimony. So antimony is having the least electronegativity, hence it should have the least bond angle, hence option number 2 is correct. Question number 38. Which of the following is not shown by nitric oxide? So we will go by the options. Option number 1, its bond order is 2.5. If I go for the nitric oxide, nitrogen plus oxygen, the number of electrons here is 7 plus 8, that is equal to 15 electrons. So whenever the electrons are less than 18, you can find out the bond order directly. That is, you have to consider the N2 molecule. N2 molecule is having 14 electrons, hence its bond order is 3, that we know. So whenever there is a variation in an electron, the bond order decreases by 0.5. That is 13 electrons, bond order is 2.5. 12 electrons, bond order is 2. 11 electrons, bond order is 1.5. 10 electrons, bond order is 1. Similarly, so if I go on increasing the number of electrons, that is for 15 electron, bond order is 2.5, 16 bond order is 2, 17 bond order is 1.5, 18 bond order is 1. So you can observe for 15 electrons, bond order is 2.5, hence the statement 1, its bond order is 2.5 is correct. Next statement is, it is diamagnetic in gaseous state. So whenever the electrons is odd number of electrons, it will be paramagnetic in nature and it will not be diamagnetic in nature, hence the option 2 is wrong. If you go for the neutral oxides, among the oxides of nitrogen, N2O and NO are neutral oxides. It can combine with oxygen to form nitrogen dioxide. Hence, the correct option is option number 2. Question number 39. Which of the following is incorrect about white and red phosphorus? They are both soluble in carbon disulfide. Remember, the white phosphorus is soluble in carbon disulfide, whereas the red phosphorus is not soluble in carbon disulfide. Hence, the option 1 is correct. Question number 40. A metal X on heating in nitrogen gas gives Y. Y on treatment with water gives a colorless gas, which when passed through copper sulfate solution gives a blue color. Y is. A metal X on heating in nitrogen gas. They have not mentioned which metal is taken in the reaction. If you observe the options, the metal in the given option is magnesium. So, we will consider the metal as magnesium. When magnesium is treated with the nitrogen, it is going to give you magnesium nitride. Actually, this is option, but we will cross check with the remaining question. When this Y on treatment with water, it is going to give you magnesium hydroxide and ammonia. Ammonia, when it reacts with copper sulfate, it is going to give you a blue color complex, cuprammonium complex. Hence, the Y is magnesium nitride. Hence, the option number 2 is correct. Question number 41. Consider the following sequence of the reaction. Sodium reacts with ammonia. When sodium reacts with ammonia, you are going to get sodamine, that is NaNH2. When sodamine is treated with dinitrogen oxide, it is going to give you sodium azide. Already we have discussed that when barium and sodium azide is heated at a very high temperature, you are going to get pure nitrogen. Hence, the pure gas liberated during the reaction is nitrogen. Hence, the correct option would be option number 1. Question number 42. Phosphine is not obtained by which of the following? White phosphorus heated with NaOH, red phosphorus heated with NaOH, calcium phosphide reacts with water, P2O3 boiled with water. You know that the red phosphorus does not react with NaOH, hence the correct option would be option number 2, because the red phosphorus is not reacting with NaOH, it does not give you phosphine. Question number 43. Concentrated HNO3 is heated with P2O5 to form NO2, NO, N2O5 and N2O. If you observe the reaction, when HNO3 is treated with P2O5, it is going to give you N2O5 plus HPO3. Hence, the oxide of nitrogen that is formed during the reaction is N2O5 and the option is 3. 44. The number of POH bonds and the oxidation state of phosphorus atom in H4P2O7 are. So, if you consider the H4P2O7 molecule, first you have to write the structure to find out the number of POH bonds. So, if you observe the structure, there are 1, 2, 3, 4. 4 POH bonds are there. So, one more thing you have to find out is the oxidation state of the phosphorus here. So, if you want to find out the oxidation state here, it will become P2O7 4 minus. So, we don't know the oxidation state of phosphorus, so it will be 2x plus 7 into minus 2, which is equal to minus 4. So, 2x minus 14 is equal to minus 4. Hence, x is equal to 10 by 2, that is equal to plus 5 oxidation state. So, here the number of POH bonds is 4 and the oxidation state is 5. So, 4 and 5, hence it is option number 4. Question number 45, the element that forms oxides in all oxidation states from plus 1 to plus 5 is. If you observe, these are group 15 element. So, nitrogen is the only element that can exhibit all the oxidation state from plus 1 to plus 5. Hence, the correct option is option number 1. This is the end of the session. I would suggest not to skip this chapter because this is one of the most important chapter, because many of the questions or 90% of the questions is a direct questions. The logical part from this chapter will be very less. So, easily you can score marks from this particular chapter. Thank you.